Hello there, folks. Hey, this is Joe Ozu here. Hey, today I'm playing with another one of these SnapSignal devices from Banner Engineering. I think they're super cool and they work great for applications where you need some analog inputs into something. In this case, I've got an S15C-U-MQ. This is the one that does 0 to 10 volts. You can also use the S15C-I for current-MQ that'll do 4 to 20 milliamp inputs. And in this case, what I'm doing here is I'm just following the spec sheet for setting up tags. And the real reason for this video is to play with some of the alarm status data that you can get out of these units. So in this case, over here in data tags, I've got all my tags mapped to the different registers. So here's my raw input at 40,001. If I go to my spec sheet here, that's this guy right here. 40,002 is a alarm state, which is this guy right here. It's the 40,002. Notice that it's a flag tag because it only has 2 states, on or off. So anything that has 2 states, we will use a flag tag. Number 3 is the status of the program. Now it has a range of 0 to 2. 0 means no error, 1 means we're below, and 2 means we're above the max here. So if I go over here to program status, notice it's 40,003. If I go to the format tab, because it has those 3 concrete values, I have hit the pick button here, and I've declared this as a multi-state. I've set up 3 states for that guy, and since they are concrete numbers, we're going to have the match type as discrete. If they were range numbers, we do something else. Let me turn that phone off. There we go. So then down here, I've got the states 0, 1, and 2, and then I've typed in the error status. So 0 is no error, 1 is below min, and 2 is above max. Right out of the spec sheet here, which is right here. That's what I've done right there. And then these other ones are sample interval time and so forth, this filtering. And then I also went a little further and I mapped the minimum analog and maximum analog read values. So you can actually adjust these ranges, and that's these other tags here. This minimum here, if I go to the data tab, it's that particular register right there, 1204, which is right out of the spec sheet here, 1204 right there. And the next one's 1205. Notice the numbering here. This is the voltage one. The current one does exactly the same. So on the format here, I've got 0 to 9 for the minimum value, and for the max, I've got 0 to 10 with 2 digits before for that one because 10 has 1 and 0, 2 digits, whereas the min, 0 to 9, I just left it as 1. So that's what I'm doing in this example here, and I want to show you how this operates. So let me download this to the screen. Got it running. There's the spec sheet. Let me go to the screen. So you can see right now that my analog voltage is currently about 5 volts, right in the middle here. I'm doing a trend view. So if I change this up or down, you'll see it ramps up. Or if I go back down with my potentiometer on my voltmeter thing, it works perfectly fine. Okay. Now, if I go all the way down to the bottom here, let's go ahead and take this all the way down. Let's see if we can get to 0, or if I can even go below 0. Let's see here. So I'm all the way down at 0, and you can see the alarm state went on. That's that flag tag. And the program status now says below minimum. So I'm at 0, or maybe below, but I'm at 0. I'm at the minimum there. So if I just go up a little bit, the error clears. And if I take this all the way up to 10 volts, or go above my 20 milliamps, we should get another error on the screen here. The purple line indicates the alarm status in this case. You can see there's a yellow line down here, which is the minimum value, and there's a red line way up here, which is the max. So let me take this all the way to 10 volts here. Watch, when I go above 10 volts, you can see that once again that the alarm state is on, and that the status gives me an above max, which is that 2 value. So if I go between that range, everything's fine, no errors at all. So let me put this back down about 5 volts. Let me do some tinkering here, team. So I'll put this at the 5 volts, pretty close to 5 volts right there. So if I say that, hey, my minimum value should only be 2 volts, so now I've got a yellow line that was right here, but now I've tracked it up to there. So that's the minimum. And then if I put a maximum, let's say I say 8 volts is my maximum here. So now I got the red line that came down to there. So if the green line goes above the red, I'll get the error. Or if the green line, which is my analog signal in, goes below the yellow, I'll get an error. So let's try it out. So if I go ahead and ramp this up to above 8 volts, you can see now that I've triggered My readings are stopped and I've got an error here. I can ramp this up as much as I want, but it's not going to read anymore because I'm way above that set point. So there's my status for that. If I come back down below 8 volts, you can see that the alarm status goes away. And if I drop this all the way down below the 2-volt threshold here, see if we get an alarm status there of being below the minimum. Let's see, here we go. There it is, now below minimum. So you can use the minimum analog read and write, not read and write, but read values here, the settings to be your trigger points. Out of the box, factory settings from these are 0 to 10 volts is the settings for the voltage one, and then for the current one, I think I have the tab open. The current one has 4 to 20 milliamps. So if it goes above the 20 milliamps, you're going to get the same error in the 40,002 register as an on state, and then 40,003 will give you the same status of whether it's above or below the max or min numbers. So out of the box, those will work fine for your application. So if you're doing something, and what really brings this up, team, is I've got a customer that's using a device that actually gives out 22.8 milliamps when they're in some error state here, and currently they're just monitoring the analog input value, and they're seeing that it pegs out at 20 milliamps. It doesn't really give them anything. So what I'm positioning in this video is that if we can use the alarm state tag to trigger as an error, then we can do additional logic in the controller they're using to say, hey, we have an alarm state here, prevent some other logic they're doing. So that's what I'm saying in this little video, and it works great, actually, completely here. So I just thought I'd make that little video. The one thing you got to make sure is that your minimum analog read value must always be less than your maximum value. It says that in the spec sheet, and that makes sense too. I mean, really, you don't want this to be greater than this. That would cause an error problem. So anyway, I think that works pretty good. If you want to copy this database, let me know. I already have all the tags mapped. So what I'll probably end up doing in my database is I'll put all these tags in a folder. And the beauty of that then is that you can just copy that folder over to your application and just change the source here to that particular device. All the tags should map the same way. So everything here is being done over Modbus 45. Here's my Modbus 45 master. Here's my device. It's drop number 1 by default. And of course, the baud rate settings are 19.2, 8.1, and none. Always remember, folks, that if you change the drop number of your device in the product, you better write it down somewhere on there so that you know what you changed it to. Although Banner's about to release some new software to help you find that, but just thought I'd show that to you. So anyway, if you got any questions, team, let me know. This works pretty good. I'm quite tickled with that that information here. By the way, I'm using the trend viewer, so I just clicked on it to show live values, but pretty cool application. Hey, thanks a lot, team. Have a great day. See you later.